Welcome to this tutorial on OpenHarmony app development. In our previous video demonstration, we showed how AI assistants can generate a complete notes application using ArkTS. Today, we'll analyze that generated source code in detail, exploring the modern development framework for Harmony OS and OpenHarmony. We'll walk through each source file and explain how they work together to create a functional note-taking application. Whether you're new to mobile development or transitioning from other platforms, this tutorial will give you a solid foundation in OpenHarmony development patterns. Before diving into the code, let's understand the typical structure of an OpenHarmony app. Our Notes app follows the standard project layout you see here. The entry source main ETS folder contains 3 key directories. Model contains our data models, Pages holds UI pages and components, and Utils contains utility classes and services. The Resources folder stores app resources like strings and images. This separation follows the model view service architecture pattern, making our code organized and maintainable. Each layer has a specific responsibility, and this clear separation makes the app easier to understand and modify. Let's start with our data model in note.ets. This file defines the structure of a note in our application. For beginners, there are several key concepts to understand here. First, we're using ArkTS language, which is TypeScript extended for OpenHarmony development. Notice the explicit type annotations like string and number throughout the code. This is because ArkTS is a statically typed language and types must be explicitly specified. Our note class has 5 essential properties. ID serves as a unique identifier for each note, title, and content. Store the notes text data, while created at and updated at are timestamps for tracking when notes are created and modified. The constructor pattern shown here allows creating notes with optional parameters, defaulting to empty strings if not provided. This flexibility makes the class easy to use in different scenarios. The generateID method creates unique IDs using timestamps and random numbers, a simple but effective approach for local storage. The update method encapsulates the logic for modifying a note, automatically updating the timestamp. The getFormatedDate method handles date formatting for display purposes. Next, let's examine noteservice.ets, which handles saving and loading notes. This file demonstrates several important patterns for beginners. The Singleton pattern ensures only one instance of note service exists throughout the app, providing consistent data access. The getInstance method checks if an instance already exists and creates one if needed. This prevents data inconsistencies that could occur with multiple service instances. For data storage, we're using OpenHarmony's Preferences API for local data storage. This is similar to shared preferences on Android or user defaults on iOS. The Preferences Manager gives us a simple key value store perfect for app settings and small data sets. All storage operations use the async await pattern for non-blocking input-output operations. This prevents the UI from freezing while data is being saved or loaded, which is crucial for good user experience. Notes are converted to JSON for storage and parsed back to objects when loaded. This JSON serialization is a common pattern for persisting complex data structures in mobile apps. Notice the try-catch blocks throughout the service. Proper error handling is crucial in production apps. When storage operations fail, we log errors and provide fallback behavior. The service provides complete CRUD operations: create, read, update, and delete. The addNote method adds new notes to the beginning of the list. LoadNotes retrieves all saved notes, updateNote modifies existing notes, and deleteNote removes notes from storage. This service layer abstracts data persistence logic away from the UI, following the separation of concerns principle. The UI components don't need to know how data is stored, they just call service methods. Now let's explore noteslistpage.ets, our main user interface. This file demonstrates ArkUI's declarative approach to building user interfaces. The component structure uses decorators to define behavior. The entry decorator marks this as an entry point to the app, while component makes it a reusable UI component. This decorator pattern is central to ArkUI development. State management is handled through the state decorator. When the notes array changes, ArkUI automatically rebuilds the affected UI components. This is reactive programming. The UI stays in sync with data without manual updates. Lifecycle methods provide hooks into the component's lifecycle. About Up Here is called When the Component is Created, perfect for initial setup. On Page Show is called When the page becomes visible, ideal for refreshing data that might have changed in other screens. The navigation system uses OpenHarmony's router to move between pages. The push-URL method navigates to the Note Editor page, passing note data as parameters. This is similar to navigation in web frameworks or other mobile platforms. The declarative UI layout builds the interface using a hierarchy of components. Navigation provides the page structure, column arranges elements vertically, row arranges them horizontally, and list creates scrollable collections of items. The For Each function iterates through the notes array, creating a list item for each note. This pattern automatically updates when the array changes, adding or removing items as needed. Builder decorators create reusable UI components. The Note Item Builder defines how individual notes appear in the list, keeping the code organized and reusable. Conditional rendering shows different UI based on app state. When there are no notes, we show an empty state message. When notes exist, we show the scrollable list. This improves user experience by providing clear feedback. The Swipe to Delete functionality using swipe action provides intuitive user interaction. Users can swipe left on any note to reveal a delete button following common mobile UI patterns. Let's examine NoteEditor.ets, which handles creating and editing notes. This page demonstrates form handling and navigation parameter passing. Parameter passing allows the editor to receive data from the previous page. The getParams method retrieves the note object passed during navigation. Based on whether a note exists, we determine if we're editing an existing note or creating a new one. Form input handling uses text input and text area components with onChange callbacks. These callbacks update our state as the user types, demonstrating two-way data binding. The UI reflects the current state and user input updates that state. The text area component handles multi-line content with layout weight set to 1, making it expand to fill available space. Conditional logic allows the same component to handle both creating new notes and editing existing ones. The save method checks the editing state and calls the appropriate service method. The navigation component provides consistent navigation experience with title modes and back button handling. Users can navigate intuitively, and the app maintains navigation history properly. Finally, let's look at string.json in the Resources folder. OpenHarmony separates text strings from code, enabling internationalization. These strings are accessed using the $R syntax. The system is localization ready. Adding languages requires creating language-specific resource folders. The framework automatically selects appropriate resources based on device settings. This is best practice even for single-language apps because it centralizes text management. Let's recap the architecture. Users interact with UI components, which call Note Service methods. Note Service manages note objects and persistence. Changes trigger automatics, UI updates through reactive state. Our separation of concerns: model defines data structure, view handles user interface, and service manages persistence. This Notes app demonstrates OpenHarmony fundamentals, data modeling, UI composition, navigation, state management, and data persistence. The combination of ArkTS and ArkUI provides a modern reactive development experience. The concepts covered form the foundation of most mobile applications. Thank you for watching.